All right, today's lesson is lesson 8.5. It's all about the properties of trapezoids and kites. So first, let's just look at the definition of a trapezoid. It's a quadrilateral with exactly one pair of opposite sides that are, or one pair of sides that are parallel, sorry. So it's usually the base of a trapezoid that are parallel. So I always say like the top and the bottom, right? Those are parallel to each other. So that is a trapezoid. You prove that by doing the distance formula. Just to reiterate the parts of a trapezoid, this is the base. This is also the base down here. And then these guys are the legs. Then all of these angles in here are known as base angles. All right, but the most important thing to know about a trapezoid is it has exactly one pair of parallel sides. You would find the slope of all four sides to prove there's only one pair. Right, so before we were talking about parallelograms, and under parallelograms we have rectangles, rhombus, and square, all of which are also parallelograms, which have opposite sides that are parallel. All right. And if at any point that I go too fast for the video, you can always pause or rewind or do what you need to do. All right, next is an isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. So here we have our bases that are parallel to each other, but now I have legs that are congruent. All right, so that means that AD is congruent to BC. Also, in an isosceles trapezoid, the base angles are congruent. So the measure of angle D is congruent to the measure of angle C. And the measure of angle A is congruent to the measure of angle B. Also, the consecutive angles are supplementary. So if I were to add A and D, I would get 180, as well as B and C. Angle A plus angle D equals 180. Angle B plus angle C equals 180. All right, once you've proved that it's a trapezoid, right, which you find the slope of all four sides, you need to find the length of the legs to prove that it is either an isosceles trapezoid or it is not an isosceles trapezoid. So you would use the distance formula to prove that. What else does it have? Oh, it has diagonals that are congruent. Oh, I didn't draw that. Hold on a second here. So that means that DB, that looks terrible. Oh, went too far. Too far. I'll write it over here on this side. So DB is congruent to AC. They are the same length. All right, next is the mid-segment of a trapezoid. It is the segment that contains the midpoint of the legs. The mid-segment is also parallel to each of the bases. So these guys are all parallel to each other, okay? So what it is also saying, then you know if this line, if M splits AD, then that means AM and MD are congruent, as well as BN and NC are congruent. Okay, so that is what that is. We're going to do an example in a second here, but I just wanted to show you what the mid-segment is. Oh, wait, we are not going to be doing an example here. I'm going to have to do an example here. Make sure you make some space on your paper. So the mid-segment is that middle line. I just want to see if I have my example next. I don't. Okay, so what I'm going to do on the side here is just to do a little... I'm just going to throw some numbers in on top of this trapezoid. If I know that this is 8, and this is 10, what I do is I add the numbers together. 8 plus 10 divided by 2 equals mn. Well, 8 plus 10 is 18, divided by 2 is 9. So mn equals 9. If I was missing, let's say I was missing one of the bases. Let's say I have 12 and that the bottom is 16 and I don't know what this is up here. So you set it up the same way, right? I don't know is usually like x, right? So x plus 16, you add the bases together, divided by 2, that equals the middle. To solve for x, I would just multiply both sides by 2 and get x plus 16 equals 24. Subtract 16, and we have x is equal to 8. So that means AB equals 8 in this case. I was just trying to give you some examples. There are some in the IXL. Sorry, I was just having a blank for a second. All right, let's talk about kites. What the heck? A kite is a quadrilateral that has two pairs of consecutive sides that are congruent. It has no parallel sides, just so you know. So the two pairs of consecutive sides that are congruent here are BC and BA. They are congruent. It also has CD and AD. What else does it have? It says the diagonals are perpendicular to each other. Remember we were doing this yesterday, or maybe you weren't here, but when we did the diagonals in a rhombus and a square, when they're perpendicular, they make a right angle. So that gives me 4 right triangles. So you can always do the Pythagorean theorem to find one side, okay? So all of the sides would be the hypotenuse. This is the hypotenuse of this triangle here, which is the same length as that one. This is the hypotenuse of this triangle here, right? So you could prove by showing that the diagonals are perpendicular. So slope of diagonals only. And then the kite has exactly one pair of opposite angles that are congruent. Well, you can't really prove that. I guess you just use a distance formula to prove it's a kite. But the two angles that are congruent are right here. Angle C and angle A are congruent. That's it. It is still a quadrilateral, so the interior sum is still 360 degrees. And B and D are not the same. Like, I don't know anything about B and D. I just know that A and C are congruent to each other. All right, now we get to do some fun math. All right, so on this graph, I'm going to graph these coordinates, and I don't know why my coordinates are so tiny. I always think I'm going to fix it, and then I don't. Okay, it's a little bigger. Sorry, when you get older, your eyes are not as good. Okay, so point H, 0, 6. So 0 for x, up 6. 1, 2, 3, 4, 5, 6. That was funny. 1, 2, 3, 4, 5, 6. All right, that's H. Then we have I is 3, 0. 1, 2, 3. And then we have J is 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. And our last point, K, which is 4, 8. 1, 2, 3, 4. 2, 3, 4, 5, 6, 7, 8. That is K. So I am now, because it's this quadrilateral, H, I, J, K, I'm going to connect those dots. H to I. I'm going to try my best to make a straight line. Ugh. No, it's okay. All right, looking at it, it kind of looks like a trapezoid. So what I'm going to do is I'm going to find the slope of all 4 sides. I'm going to do HK first. HK, or KH, whatever, doesn't matter. So 8 minus 6 over 4 minus 0 is 2 over 4, which is 1/2. If I'm thinking that HK is parallel to IJ, I'm going to do IJ next. ij, I. Oh, why did I say ij? I did mean ij, but I wrote hj. What in the world is happening here? Please forgive me. ij, okay? Because I'm thinking, I'm looking for opposite sides that are parallel. So I want to see, are they parallel to each other? So j is 9, 3, and I is 3, 0. So 3 minus 0 over 9 minus 3. 3 minus 0 is 3. 9 minus 3 is 6, and that reduces to 1 half. So it turns out that HK is parallel to IJ. I have to quickly check the other two sides because I don't know. What if they're parallel to each other? I mean, I know it doesn't look like it, but what if they are? All right, so HI is HI. So 0 minus 6 over 3 minus 0, which is negative 6 over 3, which is negative 2. Excuse me. And then KJ uh, 8 minus 3 over 4 minus 9. 8 minus 3 is 5. 4 minus 9 is 5. Oh, negative 5. Please forgive me. This is negative 1. So they are not parallel. So HI is not parallel to KJ. Not parallel. Here's where you guys always get mad at me, but it's important, okay? So I know these two are parallel. I'm going to give them little triangles. I need to know, what about the legs? What about them? Are they congruent? If they are congruent, is it an isosceles trapezoid? I'm not sure. So I need to do the distance formula. All right, and I only need to do it of the legs. So the length of HI HI and KJ only, okay? You don't need to find the length of the other two sides. So if I'm finding the length of HI, so HI, 0, 6, and 3, 0. So 3 minus 0 squared plus 0 minus 6 squared. 3 minus 0 is 3. 3 squared is 9. 0 minus 6 is negative 6. Negative 6 squared is 36. That gives me the square root of 45. Just for good practice, you should be able to reduce that. You should know that that is 3 root 5. That is the length of HI. Let's just check KJ. All underneath that big square root. All right, KJ, we have 9, 3, and 4, 8. So 4 minus 9 was 8 minus 3. 4 minus 9 is negative 5. Negative 5 squared is 25. 8 minus 3 is 5. 5 squared is 25. All right, I can see that they're not parallel. You should know that this reduces to 5 root 2. All right, so if they're not parallel, then guess what? It's just a trap, not an isotrap. Trapezoid. Not iso. All right, cool, cool, cool. Let's do some examples, and then you can get your homework, and it's going to be lovely. All right, so your second sheet of paper that you have is these kite and trapezoid examples, okay? So here is a trapezoid. I know that this is an isotrapezoid, okay? So I know that the base angles are congruent. So this is 110. That makes x 110. All right, I also know that these are consecutive interior because they're in between these two parallel sides. So they're supplementary, meaning they add up to be 180. So that makes z 70. And since z and y are both base angles that are congruent, this is also 70. If you think you can go ahead and do this without me with you, pause the video and then come back and see how you did. Okay? So moving on to the kite. All right, this is a kite. Well, I know that two angles are congruent and they're going to be J and G. So that makes J 130 degrees. I know the interior sum is 360. So 360 minus 260 is 100. Minus 84 is 16. All right, whoa, now I got this craziness happening here. Okay, so I know again this is a kite. The interior sum is 360. These two are congruent. So we take 360 and we subtract 73 and we subtract 37 and that gives us 250. Divide that by 2 because we're splitting that between these two angles and I get 125. So S and U are both 125 degrees. All right, remember I told you about the kite. When you have a kite and you have the diagonals, what it does is it creates a right triangle. I can find this length by just doing the Pythagorean theorem. 10 squared plus 12 squared equals, let's just make this x squared. So 100 plus 144 equals x squared. 244 equals x squared. And now I need to break that down, and that gives me, so I'm going to rewrite it, x squared equals, when I take the square root of both sides, 244 is the square root of 4 times the square root of 61. 61 is a prime number, so 2 root 61. All right, now we got angles to come up with. What is the measure of angle V? Well, I just showed you this box. This box exists everywhere, right? 90, 90, 90, 90. Each little intersection there is 90 degrees, so this is 90 degrees. All right, 2 more to go, darlings. The mid-segment of a trapezoid. Okay, so literally all we do is take the top plus the bottom, divide by 2. 9 plus 15 divided by 2. Well, 9 plus 15 is 24, divided by 2 is 12. So x is 12. All right, oh, now they gave us one that's kind of crazy. All right, I know that this base plus this base divided by 2 is equal to 11. Ooh, I don't know why my pen just did that. All right. It's really important that you multiply both sides by 2 first. If you were like, hey, I already know I'm multiplying the middle times 2, and you didn't want to leave this down here, and you were like, x plus 18 equals 22, fine, fine, fine. Because some of the ones in your homework are going to be expressions like 3x plus 7 or something. So be careful about that. All right, so x plus 18 equals 22. Subtract 18, and x is equal to 4. All right, hopefully that helped. If you have any questions, hit me up on the Schoology. All right, here is your assignment. I was just kidding. Hold on, here's your assignment. It's coming. All right, you are going to need to graph 3 and 5. I don't know about 7 to 27. I don't think so. I think only these two, from what I remember the homework being, are the ones that you need to graph. Let me know if you have any questions, and I hope you have a great day. Okay, bye.